Let's qualify for Yandex Cup. I believe it's a good time to do it. Smart Cat Steven. Okay, maybe we can increase the scale. Artist paintings can be represented as one-dimensional array with each color encoded with a number. The beauty of an array is equal to the maximum number of continuous segments into which it can be cut, such that the minimum numbers in each part form an increasing sequence of consecutive numbers, starting from 1. So we have an array. We want to divide it into several parts. Into several continuous segments. Such that the minimum numbers in each part form an increasing sequence of consecutive numbers of colors starting from 1. Okay, this problem is not hard, it's a greedy approach, so we go from the left to the right, and we seek for the last one. After that we seek for the last 2, then for the last 3, etc. Until we run out of numbers. Okay, it's easier not to seek for the last one, but for just any one. And we can do it using some sort of stack. Okay, let's do it. It's like if you needed to output the answer, then it would be a stack. But since we only need to find the number of such segments, we only need to... So instead of stack, we will just have a count. So here we read a number. Then we read an array. And we print the answer to this array. Again, here we find the answer. How do we do it? We say that we have a counter C, which is initially 0. Then we go through all the numbers. So if I is greater than C, and even greater than C plus 1, then we do nothing. It can be just included in the current segment. If I is equal to C plus 1, then we can start a new segment. We started a new segment, and so C is increased. And finally, if I is C, we do nothing again. And if I is less than C, then we need... So C is current answer. So if I is less than C, then it will drop the minimum to the number I. So actually, the final solution looks like this. We just we simply assign c equals minimum of c plus 1 and I. That's it. Let's copy the samples 1, 3, 0. These should be the answers. 1, 3, 0. No. Incorrect. Wait, what? If I is big, we do not need to increase C. Okay. So if I is at most C plus 1, then C equals I. Maybe like this. Okay, so if I is greater than C plus 1, then we do nothing. And if I is at most C plus 1, we need to drop to I, or maybe increase by 1. Get I. So this is the correct answer. 130. Nice. What is it waiting for? It's running. Okay, I don't know what to wait, so we will continue with B. We are part of contemporary art exhibition called Cats in Art. All the artists here grow their art in petri dishes using microorganisms instead of paint. Bacteria, mold, and fungi take different forms, mixed together and produce some truly unusual finished pieces. The theme of the exhibition is microorganism pictures of different cats. A is accepted. We rush to a special store that sells the microorganisms we need. It has n vials of bacteria. Cost of I is CI. We will buy m vials. We need to spend as little as possible. And minimize the distance from the leftmost to the rightmost vial we buy. The distance in this problem is measured by the number of the vials between the furthest purchased inclusive. Between the furthest purchased inclusive. Okay, it seems that like something with 2 pointers. It seems like something with 2 pointers. How is this 2 pointers? So we have some segment. And assume that we know the answer in here. So we know, what I want to say is that for each element, we want to know the shortest segment, which contains m vials which we can afford. Or like infinity if we cannot afford. So I guess we also store this optimal set. Now let's think what we have to do during each operation. So there are two cases. First case is this is among m minimum elements of this array. Yeah, in this case, we have to erase it and buy something new. Yeah, we need to buy something new, and we either can or not. Actually, is it true that we always have to increase our segment after such operation? Yeah, so assume that we have some so for example, let's assume that here m minimum elements are these ones, and if we have this segment, then we cannot afford m whiles. Yeah, so this means that this element is substantial for us. It's really substantial. Let's call them like a1, a2, etc. am minus first and am. And we know that a1 plus etc. plus am is at most our budget. No, what? We need to spend as little as possible. So we need to minimize the budget actually. Okay, this it's useful to understand the statement. Okay, in this case we sort all whiles by the price. Maybe the price is all different. So 1, 2, 3, 4. But here we could have 1, 2, 3 if we could. Well, so this is much easier now, I think. So we have some current segment, which is definitely taken. Yeah. Initially, it is just, I don't know. Okay, so we have some segment. And after that, we have several elements. We sort all elements in increasing order by their price, or whiles. We need to take m of them. So there are two cases. So assume that you have some group of whiles which have equal cost. Yeah, you can just, if in total you have at most m whiles now, if you add them all, assuming that they have the same cost, then we just add them and our segment is increased. It's the first case. And the second case is if actually this sum will be greater than m. That means that we need to only leave like m minus current m. This is a number of whiles we need to take. And we need to choose them in a way that minimizes the length of this segment. And this can be done with two pointers. So it's actually much easier than two pointers. So we read n and m, or m and m. No, n and m. Then we read all costs. And then we print find answer cm. Okay. Now it might be a little bit more difficult problem. So I think the easiest way is just to sort them. Yeah, so let's sort them. We have vector int indices. Where we just put all our indices. So indices I equals I. Then we sort them with a custom comparator. Sort indices dot begin indices dot end and comparator which just says that if vi is not vj, return vi less than vj. Otherwise, return I less than j. And here we close the parentheses, and the sorting is done. Great. After we have sorted the indices, we iterate over them. There are actually some C++ 20 ways of doing it. But we will do it our way. So we just have vector int segments. And we iterate over all numbers. Great. So how do we do it? So if segments dot empty, we just need to add a new segment. Which consists of one number, which is I. Great. Otherwise, it depends on whether the cost of this I is same as the maximum cost in the segments. And this means that we can just add here or segments dot back has the same cost as vi. Oh, not. It has not the same cost as vi. Otherwise, segments dot back dot pushback I. Great. This simple function provided us with all segments grouped by the cost. Then we iterate over our segment. So here we have int current, which is 0. So if, and we also have our current segment, which like int l equals like n and r equals 0. Something like that. Yeah, so if int new car equals car plus segment dot size. So if new car is still at most m, actually we can start with if car is at least m, then break. If new car is at most m, then we just add it and that's it. So we say that car equals new car, L equals min of L and segment dot front, and R equals max of R and segment dot back. Great. +1, I think. Or not. Okay, let's say that L and R are our segment ends inclusive. In this case, just like this. And in the end, we return R minus L plus 1. And here we continue. So here we need to stop. We need to only add m minus car numbers. And we just iterate. So we say int ans equals like n. We iterate over all ways. What are the ways? We need to take ans equals minimum of ans and our new distance. So the distance between R and L plus 1. Okay, and here return ans. But instead of R, we need to take maximum of R and segment I plus to be added minus 1. And instead of L, we take minimum of L and segment I. So we want this to be a valid index. We can just write like this. So this is less than segment.size. Since I don't like this minus 1, we can replace it with this. Or even with this. Is it correct? So let's check. If to be added is 0, is 1, then we just need to iterate over all numbers. From 0 to segment.size minus 1, and this is correct. Fine. Fine, I guess this is our final solution. And we need to test it on the samples. Ideally, we also need to test it on something else, but I'm not sure we will. 5 and 4. It is believable. It is definitely believable. Running. Actually, this can fail because, well, I didn't check it at all. I only checked some samples and they worked. But this doesn't make me sure we won't get a VA. Okay, this is a full solution. Our solution is rather fast. We like it. So now we want we have numbers 1, 2, etc. n, which are paints. And we define a paint mixing sum as sum for all I and j of their bitwise end. And we want to find it. Okay, this is pretty standard problem. How would one do it? So we have sum of 1 from 1 to n, sum from j of j from 1 to n, I and j. Yeah? So let's rephrase it. We have sum of I equals 1 to n, sum of j from 1 to n, and now we iterate over all numbers which are which are included in both I and j as bit sets. Okay, so I in binary is a string of ones and zeros, and each digit in this representation corresponds to some position in binary. So k is the set of these positions, and we take here 2 to the k. After that, we can rearrange it and say that we firstly iterate over all k's from, I guess, 0 to 60 to 59. And then we actually, instead of 59, we would like to have binary log of n down. Fine, then we iterate over all i's which have k. Then we iterate over all j's which have k. And we take 2 to the k. Instead of that, we can take in beginning 2 to the k, and then we sum I over k and j over k. J containing k, I mean. And this is simply the number of such j's. So this is sum of 2 to the k times sum of I containing k, number of j's which contain k. And in the same manner, this is the same thing. So we can rearrange it as 2 to the k times the number of j's which contain k, sum of I containing k1, and finally this is just simply 2 to the k and number of j's containing k squared. Nice. And we need to calculate this thing. So now we have the following question. How many numbers between 1 and n contain k as a bit? It's not a particularly hard question. Yeah, so how the life goes on. So we have 2 to the k numbers which have 0 in this kth bit. Then we have 2 to the kth numbers which have 1 as this bit. Then we have 0 again. Then we have 1. And then at some point we either stop here or we stop here. So what I want to do in the beginning is I want to calculate the number of these numbers. So which are ones in full blocks. And then I want to calculate the thing here, which is partly a block. Okay, does it make sense? So let's do the both things. So we have n. We want to calculate the number of full blocks. So the number of full blocks including zeros is just like, let's think that if we have, so first of all we have 1 to n. Let's replace it with 0 because we don't mind. Actually, if we replace the index to 0 with 0, it doesn't change the sum because 0 and anything is 0. So we start with 0. And instead of this segment, we will consider this semi-segment, semi-interval. And now we want to look into where this element is, n+1, where this element is. This will be n prime. Okay, we have an n prime. And I want to say that, so first of all, we want to find the number of full blocks. And now this is simply n prime time over 2 to the k. Then we would like to find the number of ones. And this is this number. So the number of 1 blocks is this number. Then we want to find the number of ones there, and this is this number. So n prime over 2. No, it was not true. No, because here we have this thing. Great. So the easiest thing is behind us. Now we need to find this. So we have this pointer somewhere here. What is the number of these numbers? I want to say it is simply n prime mod 2 to the k plus 1. And then we need to subtract all these zeros. So this is maximum of 0 and this thing. Nice. So this is how we go. Now we read n t. We read t and n. So we read here t. Here we say that if not solve test, then return. Here we read number n. Here we print find ans of n. What I would like here is to add one. Yes. Here we iterate over all numbers from 0 to 59. To fix this. Bam, bam, bam. Great, we read number of paints, we iterate over all of these. So here the answer for k is the following. We take n over 2 to the k plus 1 times 2 to the k. Then we add maximum of 0 and n mod 2 to k plus 1 minus 2 to the k. And all of this is multiplied by 2 to the k. Great. So what I would like to have here is a function which calculates the residue. We have product of a and b. We say return long a times b percent n. What's wrong with you? Yeah. Here we have int answer, which is 0 initially. I think we would like to have a power of 2 current. Here we say that P2 is sum of P2 and P2, where sum is modular. So we also have to add if A plus plus equals b is at least m, a minus equals m, return a. Great. So now we need to divide n prime by 2 to the k plus 1. Yeah, so we divide it, then we take it percent m. I think we can just do this. And then take it percent m. So this is this left part. Then we need to take the right part, in which we take maximum of 0 and okay, maximum of 0 and n mod 2 to the k plus 1, which is this. And all of these, from all of this we subtract 2 to the k. Finally, all of this is taken modulo m. And after that, we say that answer is sum of answer and product of p2 and all of this. Totally nice. What's wrong with you? Are you nuts? Ah, you're not nuts. Okay. The Visual Studio assists us. It says that it is possible that here is some bug, and there is actually a bug. We need to take one LL here and here. When we fix it, it should be okay. Let's check. Oh. So is the answer correct now? 1, 3. Okay, the third sample is not correct. The third sample is definitely not correct. Yes, for some reason it said that it is not 120. I don't know why. Let's check. This shouldn't be particularly hard. Okay, I only want 3, so let's do it like this. So we're starting with 0. So we have some sort of P2 and answer. Okay. Okay, yeah. So we have numbers 1, 2, 3, 4, 5, 6, 8. Ah, of course, we need to take a square of this number. So this nice number should be squared. Yeah, so we have this nice number int number, which is this. And here we multiply it by itself. And this should be correct. Now it's even worse. Ah, it's not worse. I just took 3 for some reason. 1, 3, yes, yes. And this is now incorrect. This is because I failed to make modular operations or long operations or something like this. We can recheck everything, I think. So we have const long n. We divided by 2 the k plus 1, then we moved it back into longs. Then we took it percent %m. Ah, this is... What? No, this is... This is no good. Ah, it should be at most 59. Or less than 60. I think this is the bug. Thank you, Yandex contest, for nice tests. We have several compositions. Each composition has a mood, which is a number, which is an integer. We have... So this is a construction problem. We have some length of an array. We have now some number of requirements. Each requirement says that we need this subsegment to be at least or at most this number. Sounds like linear program? Oh man. We have some sort of linear program. I don't like it. I don't think this is a general linear program, especially because all functions are of form something like this. It's at least something like this. Ah, okay. This is a totally standard problem. So let's consider these variables. S1, which is A1, S2, which is equal to A1 plus A2, etc. Sk equals sum of AI from I to k, and finally Sn is the sum of all numbers. Then we can choose any integers and set these Sns to these integers. And it is easy to take such A's, which will correspond to this Si. We can also take S0, which is 0, and we cannot choose S0, but actually we will not need to do it. After that, let's consider, for example, segment from AL to AR. this is simply SR minus SL minus 1. So now we have several inequalities of form that a difference of two numbers is at least some constant, or at most some constant. And we need to check whether we can find such numbers as I, which satisfy all these inequalities. One would say that we cannot choose S0, but actually we can choose S0, and if S0 is, for example, in the optimal solution is 3, we can subtract 3 from all numbers, and now S0 becomes 0. Yeah, so instead of... So we can just choose all these n plus 1 numbers, including S0, and in the end we just can subtract S0 from all numbers. Fine, so we have several inequalities. We need to check whether we can satisfy all requirements. This is also some sort of standard problem. Let's make all these inequalities with this sign. Yeah, so how can we get a contradiction? We can get a contradiction if we have a minus b is at least... Let me write it like correctly. We only have a contradiction if we have that SA1 minus SA2 is at least C1, SA2 minus SA3 is at least C2, or let's take at most, for example. Let's take at most. SA3 minus SA4 is at most C3, etc. And finally, SAK minus SA1 is at most CK. And if we sum it up, we get that 0 is at most C1 plus etc. plus CK. And we will not like if this is negative. So actually, we can construct a graph in which for each restriction we have an edge from like A1 to A2 of weight C1, etc. So we have a graph, and we need to check whether there is a negative cycle in this graph. This can be done with Bellman-Ford algorithm. Let's do it via Bellman-Ford algorithm. So in the beginning we read n and m. We read them. We read them. And then we have several inequalities. So vector pair int no pair int v size m, iterate over all numbers. Read vi dot first vi dot first dot second and vi dot second. I would also like to subtract 1 from L. So here I say that minus first, and we want to print this answer, and depending on it either yes or no. We use small letters or only capital? No, only capital letters. Great. Now we have bool find ans. And const this structure v. Right. So this vector v is actually just a oriented graph. How to check if there is a negative cycle in this graph? To do it, we need to start with all zeros. Yes, so we have vector. Can we choose ints? I believe we can just choose ints. Yeah, because if we do it 2000 times, it'll still be not much. Int potential size n, which is initially 0. We iterate a bool. Something happened. Equals true. And then we need to return not happened. So here we say that nothing happened. Then we need to iterate over all edges. And ask if we can improve our answer. So we can say int new pod equals, no, I was mistaken. It should be n+1 here. And also, I was totally mistaken about this one. So if we know that si minus, so we know that sr, okay, first of all, we have edges from R to L, okay? So what we have here? We have here either AL plus etc. plus LAR is at most, is at least C, or AL plus etc. plus AR is at most C. So this goes into this. SR minus SL minus 1 is at least C. And this, so this goes into edge from R to L minus 1 of weight C. And it goes into SR minus SL minus 1 is at most C, which goes into SL minus 1 minus SR is at least minus C, which goes into an edge from L minus 1 to R of weight minus C. Great. So now we need to change our reading. String S. Okay. So if S 0 equals greater, then we just need to swap the beginning and the end. Swap vi.first.first, vi.first.second. And otherwise, we need to say that vi.second is just minus vi.second. Yeah? Yes, I think so. Right now we have new potential of vertex edge.first.second, which is edge.first.first. We take its potential and it we add edge.second to it. So if new potential is less than current potential of edge.first.second, we say that something happened, and we update this potential. Nice. Why is it this? Because I even think we can replace it with less, but let's do it safely. Okay, now I guess we can check it. No, and that's it. I don't like it. Why are there so many? Oh, this is understandable. So no means that it returned false. And it means that it found a negative cycle, which is nuts. How did it find a negative cycle? How did it find a negative cycle? What is V? It somehow found a negative cycle. I don't like it very much. But what can I do? Ah, okay. I want the inequalities to form that something is at most CK, not at least. This means that I need to fix everything. So actually here I need SL minus 1 minus SR is at most minus C. Yeah, so I actually need here to do this. And here I need it this way, so I just need to slope SR and SL minus 1. So I only need to make this beautiful change. And now it suddenly works, doesn't it? Yes. And maybe this will output as no. Okay, it found a negative cycle. Totally understandable. Let's make it 20 and it suddenly works. Yes. Okay, I think we can submit it. I don't see a reason why to wait more time. So it have passed 10 tests. It has passed 10 tests. It has passed 10 tests. Fine, problem E. What is that? There's some functions. So we have a drum machine. What is it? We have an ordered set of linear functions. So we have a set of linear functions. We remove one function. We need to solve this equation. So how it is done? How it is done? Yeah, so we need to solve it. Ax plus b equals 0. Yeah, so actually linear function is this vector, is a vector of a and b. Yeah? And how do we make a composition of two linear functions? Yeah, so for example, we take c ax plus b plus d. What is that? This is linear function ac x plus bc plus d. How can we apply it to this to get the right one? ac bc plus d. Actually, this is a matrix C0 what? I don't like it. So we need something like okay, this can't be done with 2 elements, I guess. But we can do it with 3 elements. So let's store A, B, and 1. And we want to have AC, B, C plus D, and 1. And to do it, we multiply this row, or this column, by the following vector, or the following matrix. So 0, C, D. Okay, so we have this matrix. Yeah, and in the end, if we have just these matrices, I guess we can take... In the end... In the end, we just need to apply it to a function x. Yeah, which is 1, 0, 1. So we get the sum of the first and the third row. Okay, okay. We have something like AB1, and then we divide B over A. minus b over a. Excellent stuff. I think. Maybe we can do it in the reverse order. So we have several matrices. We have several matrices. So we need to calculate something. Yeah, we have like some matrix product. We need to calculate it, and we need to be able to add some matrix in some place. Oh. Okay, I think this is some sort of segment tree with updates. Yeah, this is some sort of segment tree with updates. This is segment tree with matrices. Okay, so let's do it. We actually need to find an invert modular sum modulus. How do we do that? If a return like a equals 1, 1, and I don't remember how to do it. I definitely remember that we need to find inverse of m%a and a. And we definitely need to multiply it by m. We definitely need to subtract it from 1. Maybe that like this. Maybe like something like this. I never can memorize it for some reason, but it seems correct. Okay, so find ans, integer. No, not integer. We need n numbers. So this is a vector of int. And we need all linear functions, which are vector of pair intent L, and also vector of ints indices. Here we need to read these functions. We need to read these functions. We will read them. Afterwards, we have vector int p. And we have a vector int p. Of size n-1, and we read it. Among the remaining functions. Oh, I don't like it. I really don't like it because it's messy. It is really messy. Yeah. No. Oh my god. I don't want to use like element by position or something like this. I can just use a segment tree, but why are you asking me to make 2 segment trees instead of 1? So, fine. Uh-huh. Okay, let's find the answer. We will need 2 segment trees. First is called sum segment tree. Which can change an element, and which can find the sum. Okay, I don't know what it can do. Okay, how can I find? Okay, let's do it the bad way. Vector in sum s of size n times 4. Okay, we have int add, which is like adding vertex 0 from 0 to n, vertex v, value val. the void add int vertex int vertex L int vertex R int position int value. So if vertex, if VL is greater than P or VR is at most P, then we do not do anything. Return, just return. Otherwise, we say that if VL plus 1 equals VR, and then we simply add it to the sum. Otherwise, we add to vertex times 2 plus 1 VL plus VR half position value. We add here and I say that int s vertex equals s vertex times 2 plus 1 and s vertex times 2 plus 2. Fine. Now let's calculate the true indices. True indices. No, without -1. Let's iterate over all numbers. Okay, so let's have a segment tree which has all ones on important positions. So segment tree of size n, and initially we say that it's all ones. Okay, now we iterate over all operations. So what do we do? Yeah, so we have several ones in our segment tree, and we want to find ith one. How can we do it? Let's divide us into two segments. So if here we have at least I plus 1 once, then we go to the left side. Otherwise, we go to the right side. So I, because we start with 0th. We start with 0th one. Okay. And it is called int ith one, I guess. So we have like int s. No, not int s. Okay, and we return ith one of vertex of 0, 0, n, p. Vertex int vl, int vr, int p. Okay. We look at the left sum. First of all, if vl times, if vl plus 1 equals vr, we just return vertex. No, not vertex, but VL. Otherwise, we check if sum of s of vertex times 2 plus 1 is greater than p, this means that we just go to the left part. Otherwise, we have to go to the right part. And instead of p, we search for p minus s vertex times 2 plus 1. Why is it? Whatever. I can do it like this and it won't go crazy, but I don't like it. Why is it asking me to do it? Great. So now we can find the true indices. Yeah. How? So we find the true index, which is st.ith1 of vi for some reason. And after that, we subtract it. Subtract true indices I minus 1. Great, now we finally have all our operations. Then we can go from end to the beginning. Yeah, so like vector int ans n. Okay, matrix segment tree we have, which is also of size n. Let's settle down the interface which we want to implement later. Structure is. What interface do we want to implement? So first of all, we need a constructor of several matrices. Then we need to find all the answers from the beginning to the ending. Okay, I also would like to find the final answer. Okay, true indices. In the end, I can just add it. True indices dot push back st dot ith1 0. Yep, the last linear function. I construct this dummy segment tree. I iterate over all segment trees that I have, or over all matrices that I have, and I need to add assign ith linear function should become linear function of what? Let me think. linear function of L through indices I. Yes. Okay, then I assign it. Then I need a pair int calculate linear function of mst.findRoot, and if lf.first equals 0, then we return, not return, but ans I equals -1, else it is equal product of minus b and inverse a. Great. So we just have several functions which we need to implement, starting with product. Here we just return a times b %m. And here it is quite standard. If a plus equals b minus equals b is less than 0, then a plus equals m and return a. Also, I'm sure we will need sum. Great. Now we need to make a structure for a matrix. Which is simply a vector of, not a vector, I would like to use an array here. Which is an array 3 by 3. What's wrong with you? Ah. So, basic matrix is just, we say that MII is 1. Okay. Now we need to construct a matrix with of linear function. Okay, I think I can just create a constructor. Yeah, so how do we do it? So it should be m00 equals first, m01 equals 0, m02 equals 0. Then we have 0cd, 0cd, and finally here we have 001. Great, this is our matrix. So here instead of linear function we use matrix. Then we need to calculate linear function, and I think we can make it a method. Okay, let's make this method. How can we do it? So first of all, we need to put 101 into it. Yes, so we just add the first and the third column. And then this is simply A and B. So we need to return sum of M00 and M02 and sum of 1, 0 and 1, 2. Nice. Then we need something here. This is simply the same. We just have... Also, we need to find a product of two matrices. Matrix operator times bonds matrix other. We take matrix. Okay, I would like... Let's do it like this. Int 2 equals 1. So if I equals j, then u, otherwise 0. Do I have time? Not much. And this is only problem E. Will I also have problem F? How do we multiply? Answer 0. And we go through this. And we say that answer I k equals sum of answer I k and product of answer I j and other jk. No, here I need to use m, and here I need to use ans.m. So ij, jk, and it gets into ik. Yes, and I return answer. And here I need to use const. Nice. And we have matrix segment 3. We take vector matrix v of m, v just. V for n. No, this is not MATLAB. Here we need to make this method int n. Okay, so we need to make two functions, find root and assign, and both are really easy. Let's start with find root. This is just return v.front. Then we need to assign. So we have a position and we have a new matrix. Great. How can we do it? So we just call a bigger function assign, which says 0, 0, n, pm. What's wrong with you? Ah, okay. So again, we have vertex, VL, VR, V, and matrix. Okay, so if VR equals VL plus 1, we just simply say that V vertex equals M and return. But not that easy. We also need to say that if VL is greater than P or VR is at most P, then we simply return. Okay, otherwise we need to assign in both parts. And say that the vertex equals the vertex times 2 plus 1 times the vertex times 2 plus 2. Okay, that's it. I believe we can copy both samples, and we also need to find out what's wrong in solution. Find ans must return value. Okay, return answer. This works. I can just submit it. Nothing wrong so far. However, as you see, I don't like such technical problems. See, I spent 40 minutes, although I totally knew the solution. Also, it's var3. Why? Maybe I don't print -1? Okay, let's assume that I have three linear functions, which are 0, 1, 0, 2, and 1 and 2, like 8. To x minus 2. And then I return, remove 2 times 1. This is correct. Okay, now I really don't know what's wrong. Maybe this function is not true, but why would it be? Let's check the function. Okay, I think this input checked the function. It should be fine. Okay, let's recheck something. So assume that I have function a and b, and I multiply it by c, d. So here we have ac, zero, 0, 0, AC, AD plus B, zero, 0, 1. Does it look like I had a function cx plus d and I put it into a times this plus b? Yes, it totally looks like it. It should be correct. Okay, let's do something crazy. Let's check our function which calculates the true indices. Yeah, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, first of all, let's remove 7, which is 7. Then let's remove 4, which is... Okay, I want to use minus these numbers. Oh, so 7. So here will be true indices, and here will be fake indices. So 7, 7, 4, 3, 2, 10, 8, 5, 9, 1, 6. So fake indices will be 7, then 4, then 3, then 2. Then 10 is just 6th. Then 8 is just 4th. 5 is just 2nd. 9 is just 3rd. Then 1 is just 1st. And that's it. 7, 4, 3, 2, 6. 4, 2, 3, 1. Let's check if it finds the correct indices. This test. 6, 3, 2, 1. Yeah. 9, 7. 4, 8, 0, 5. It's totally correct. It's purely correct. Ah, I should have done true indices here. This is a mess. Why didn't I do it? Okay, let's just send it again. I had poor testing for sure. Why did it work with these tests? This is strange. And now it's okay. It should be okay in the end. Okay, X over Y sorting. Although I have only 10 minutes, I don't think I will be able to do it in time. So we have array X and array Y, and we take a multi-set of fractions in which the numerator is X and denominator is Y. We need to find kth order statistic of A. We need to update xi and update yi. Very interesting. What is this word? There is no such word in English. Warranted. What the hell? Okay, since I don't know how to solve this problem, million? Million? How to solve this problem? Sorry. Sorry, what? So I guess I can consider it this way. We have a graph and we have a lot of points and we need to sort them by angle. And the points make up a matrix, like a matrix of points. Like Cartesian product of two sets, one horizontal set and one vertical set. And we need to sort them by angle and find k order statistic. The small problem is that this set is of size 10 to the 12, which is crazy. Okay, it is okay now. In 478 milliseconds. Okay. Guaranteed minimum of n and m times q1 So they do not ask for the order statistics a lot. So we can just find the answer in how much time? You can find the answer in O of n time, where n is like minimum. Okay, so we have two sets. How do we do this update in O of n time? Not update, but how do we find the answer in this time? Maybe this is some sort of binary search? Yeah, where we still it's strange. How do we do this binary search? So we have this. We need to find how many points are there. This ain't easy. This is not easy. Ain't easy at all. Maybe this is easy. Yeah, so if this is n and this is m, we just need to iterate over all these things. For each of them, we need to find this size, which is like, again, order by element. Okay, I can make an tutorial of this problem, but I don't want to solve it in language because I want to sleep. The solution is as follows. So you have a special structure called ordered set, which can do three things. You can add an int. You can actually ordered multiset. Ordered multiset. You can add int. You can remove int. and you can find order by element. What is that? You are given an int, and it finds the number of elements which is at most this parameter, for example. Okay. So after that, there are 3 operations. So this operation is simply remove some element from the X set and add it to the Y set. Actually, let's assume that n is at most 10 because the rest of the problem is symmetrical. And assume that we put n here and m here. So xi equals c, we just update it. We just simply update it. We just store x as an array. So when we take that yi equals c, we remove, we also store an array y. We remove yi, we say that yi equals c, and then we add yi. And finally, the third operation is kth order statistics. To do it, we iterate. So we make a binary search. So we need to check for a line whether the number of points here is at most k. And we can do it in O of n times log m time. We iterate over all these columns, over all elements of x for each of them, assuming that this angle tangent of this line is alpha. We need to find the number of elements which are at most alpha xi in y. Number of elements which are at most alpha xi in y. And this is y dot order by element of alpha xi. Down. Floor of this number. So we sum them up. We find it in n log m time. And also we need to make it times, I don't know, maybe 20 for the binary, 40, I think it's 40 for binary search. So this is the final asymptotics. So what is it about asymptotics of it as a whole? So Q3 is done in O of 1 time. So we just have Q3. For Q2, we need to make an update in one set. So it's Q2 log m. And here we have n times log m times 40 times Q1. This is known to be at most 1 million. So the total asymptotics is like u log m plus 40 million times log m. And this is kinda okay, because log m is at most 20. So this kinda works. And we have 5 seconds, so it should work. But Visual Studio, unfortunately, does not have advanced set, ordered set, which can find statistics by element. So I will not implement it, alas. But after all, thank you for watching.